For this example, we have a system of three linear equations that we want to put into triangular form, and then once it's in triangular form, we can identify solutions if there are any. And so when a system is in triangular form, the first equation should have an x term, a leading term that has a coefficient of 1, which this satisfies that. So the first equation is fine. And now we can use this first equation to eliminate the x terms in equations 2 and 3, which shouldn't have any x terms in them. So what that means is we can start by replacing equation 2 with minus 2 e1 plus e2. So I'm going to take the first equation, multiply it by minus 2, add it to the second equation, and that's going to be my new equation 2. So equation 1, we're not changing, since that is looking good already. We have x plus y plus z is equal to 2. And now when I do this operation, minus 2x and 2x cancel, minus 2y and 2y cancel, minus 2z plus z gives me minus z, and on the right side of the equation I have 2, and that's because the minus 4 plus 6 gives me 2. And we've got equation 3, which is 4x plus 4y minus 4z is equal to 24. And so this operation not just eliminated the x terms from equation 2, but also the y's. And that's okay. We don't have to have y terms in the second equation. Next, let's go ahead and replace E3 with minus 4 E1 plus E3. So we're going to take equation 1, multiply this by minus 4, and then add it to equation 4, and that's going to kill the x term in equation 3. So equation 1, we have still, we're not changing this, is x plus y plus z is equal to 2. Equation 2 we have is minus z is equal to 2. And now equation 4, the minus 4x and positive 4x cancel. The minus 4y and the positive 4y cancel. I've got minus 4z minus 4z, so that gives me minus 8z. And the constant on the right side is going to be minus 8 plus 24, so that gives me 16, positive 16. And now we're almost there, so we have no y terms in equation 2 and 3, and that's okay. But let's go ahead and make the leading term in equation 2 have a coefficient of 1. So I'm going to get that by multiplying equation 2 by minus 1. And so that's going to give me equation 1, x plus y plus z is equal to 2. Equation 2 now becomes z is equal to minus 2 when I multiply that equation by minus 1. And equation 3 is 8z equals 16. And we're not quite done. I could take equation 2, combine it with equation 3 to eliminate the z in this last equation. So the last thing to put it into triangular form is we're going to replace E3 with 8 times E2 plus E3. And going back to the previous step, that means I'm taking this second equation, multiplying it by 8, and adding to the third equation. So the 8z and the minus 8z, they cancel each other, and that gives me 0 on the left side, and the 8 and the minus 2 gives me minus 16, and that also cancels the 16 over here. So that means the top equation, that is x plus y plus z is equal to 2. The second equation we have is z is equal to minus 2, and the third equation now becomes 0 equals 0, since all the terms cancel when I do this last operation. So this is now in triangular form. And what we can see is that no equation has y as a leading variable. So we say that y is free. So any solution to this has to, first of all, is going to mean that z has to equal minus 2. And I could take this and plug it into the first equation to see what that tells us about x and y. So this means that the first equation would then become x plus y, z is minus 2 equals 2, which means x plus y is equal to 4. So as long as z is equal to minus 2 and x plus y equals 4, we're going to have a solution. So there's lots of values of x and y, in fact, and infinitely many, that add up to give me 4. So this means that our system has many solutions, in fact, infinitely many. So we say that this is a consistent system, since there are solutions, and we say that it's dependent, since we have more than one solution. And the way that we can write out these solutions is we can parameterize the free variable. And so we say, okay, we can let y equal t. We could choose any letter here. Just the convention is normally we parameterize the free variable with the variable t. And this tells me that solutions are going to have, well, we saw z is equal to minus 2. Y we can let be free, so it can be anything. And once I pick values for z and y, this means that x plus t is 4, plugging this in over here, which tells me x is equal to 4 minus t. So here's the condition on x. Y is free, and z has to equal minus 2. So we could write out our solution as x, y, z is equal to, well, x is 4 minus t, y is free, and z has to be minus 2. So there is our solution to this system of 3 equations. Because there are many solutions, we say that it's consistent dependent system.